given that I'm vertically challenged, I feel like I should just stand most of this panel because I won't able to see the faces and so on. So maybe I will just be standing, and it's all pretty informal, folks. This is not like a big, some PR event run by some commercial company or something. It's just us, the students, us, and our many of them being our alumni. If they're not alumni, they certainly are our well-wishers and friends. Okay, the topic was shaping tomorrow's workforce. Okay, before we go into the actual discussions, I just want to tell you a little bit about the logistics of the panel. First thing, I'm going to request the panelists to be brief because we have a lot of questions. I've already told them that. Okay, so with that, without further ado, actually I wanted to ask a question that is not here. Many of these questions are a little specific. I want to ask the first question to one of each type of people we have here. We have two from startups, two from industry R&D, and we have actually only one there from the faculty. I want to ask the first question to just as a warm-up that, let's say maybe Aman, you, because you're here right next to me, and maybe Vrinda, and then Shivram, as to if you could shape tomorrow's workforce, you had some magic wand by which you could shape the workforce exactly to the way you want. What would that shape?
In computer science department and generally people from engineering domain that I've seen, people are generally very good at very vertical thinking, right? So this is coming, by the way, from a startup founder. I'm not a part of a large corporate. So all I'm saying, I've seen people who are very good at one thing and they are able to do it very deeply. This is extremely useful in large corporates. So let's say if I'm joining Google and I'm great at building search engine related algorithms, so that, it makes me a perfect fit candidate for a large company like Google. So when ma'am asks what according to you, would do to get an ideal workforce. So first of all, for me, for a startup founder, an ideal workforce will be someone who can think a little more horizontally rather than just going deep, right? And that requires a lot of second order thinking, which means if I do this, what impact will it have on other processes? Simple example, right? We have a small team, right? I started my new company 1.5 years back, so about 20-25 people in the team. Engineering team makes a small change in the product. Maybe it requires some extra parameter while logging into our product, right? Very simple example. Sales people are not aware of it, and in front of client demos, they are goofing up. It happens all the time, right? Sales and engineering teams fighting with each other. So now the engineer who is developing that feature, he did a great job building and engineering, making the product maybe more secure. Let's say they developed that feature for additional security, but they forgot the second order impact that ultimately this is impacting my sales team. They need to be coached that this new feature has been added, and please be mindful of this feature when you are showing it to the client. Otherwise, your usual sales demo pitch will break. This is a simple example. So for me, an ideal workforce would be someone who can think a little more horizontally rather than just vertically. So T-shaped learning curve where you are good at a lot of things, but extremely good at one thing. That's the kind of ideal workforce I can envisage would work very well at startups.
Thank you. Vrinda?
Yeah, I think I agree with Aman. That's, I think, better answer than what I thought. And I also agree, like I have seen, even in large companies also, that is somewhere the issue is there, that some people, even management people should also know about tech a bit so that they can manage well. So yeah, I agree with Aman what he said.
Shivram?
Yeah, so I think I need a slightly more powerful magic wand than Vrinda and Aman, because here's what I would like, right? I would like youngsters to work on the most important problems that the world is facing today, many of which are not in companies' interest to solve, many of which are being, if anything, prolonged, right, on account of more myopic short-term thinking. Your future, more than mine, depends on global warming, right? The rate at which our world is warming up. I'd like most students to look at something like that. Even if we stick, I guess, in the context of computing and AI, the world is not all about LLMs, right? As we are sort of made to think today. There is so much more about human beings, how they interact with AI, about how much heat AI is producing. There are many problems, I think, which are very important for, our future. which are not currently in the crosshairs of industry, right? It's not what shareholders are interested in. I'd like to wave my wand and make all of you all work on those things.
So I'll ask one more question and then we'll just open it up. Maybe Priyanka, what are the key differences in doing research in academia versus industry, and how should one decide between the two? So you can give, you've done PhD in academia and work in industry.
Yeah, so it's a very good question, and it's something that always comes in anyone's mind. So academia is something that's very open-ended, and it gives you a lot of flexibility on what problem you want to solve. As Sir said, that you can work on global warming that industries are not currently working on that way, right? But that is one aspect of things that academia gives you. But in the industry, you can you work with the problems that your clients are facing, or you can do a direct impact through your research as well, right? You can see your research being in a product that's working, that's being used by a lot of users. So I think it gives you a sense of satisfaction as well when you see your research or your work going into some product. So there are pros and cons of both, but I feel there are different things that excite you that way. So the openness in academia versus the application of what industry provides is the key differentiator.
Thank you. Nagarajan, if you want to also add to that, and I also had a follow-up actually, which is very related, which maybe Vineet can answer, that what is the role of startups in driving research and innovation today, and how do they differ from academia and industry? So Nagarajan first and then Vineet.
So before I start, I also make a point, a response to the point that Priyanka made about academia today can actually work on anything they want. If they want to work on global warming, they can't. But unfortunately, the politics also dictates what you want to work. So given the recent political climate, I don't know if you can work on global warming. So that bit aside, there are long-term problems in both academia and industry. For example, Microsoft had this recent breakthrough in quantum computing. So, and I recently learned that Microsoft has been funding that team for 17 years. So Microsoft Research took that sort of long-term vision, which is fairly long-term. In fact, it was not even clear that this research is going to pay off. We have some breakthrough now, and we don't know how long this will sustain. And if this breakthrough is actually real, that we'll actually have something tangible in the coming decade, but we'll continue to support that kind of research because if you think of companies betting on these research agendas, they will want to put some non-trivial amount of chips on projects that have very high impact if they succeed, right? So companies will always want to take such bets, whereas academia can do a little bit more relaxed in these kinds of betting. They can put somewhat more evenly. Whereas academia cannot, industry cannot afford to put these bets evenly, but they will still have to make bets on these improbable success events. But if they succeed, it'll be very huge. Yeah, thanks.
Thanks. Vineet, what is the role of startups in driving research and innovation today?
Okay. So firstly, thank you for inviting me here. Very happy to be here. So what I realized when we started this company, and I've been part of this for like now two and a half roughly years, is that the process actually doesn't change. It's the fundamentals that change. So here also we ask questions. So like in research, we ask questions. We have some broad set of problems that we are interested in. So here also we ask questions. What are the problems that could actually have impact? The real difference is that this needs to have an economic impact. And now you really go and think, what would you require to actually build this product out? Would you require a lot of research? Would you require a lot of engineering? What is the trade-off? Can you get the product out very quickly? Can you not? And then it's short-term game versus long-term game. And then there is a real amount of effort on distribution. So the research aspect comes very late. It is actually about the question and what kind of impact can this question have? If you solve this problem, what is the economic impact? How can you sort of be profitable as well as help the community? So this is essentially the difference. In research, you are sort of happy if your question is interesting to your research community, to your academic bubble. Like So if you are sort of happy with, if your community is sort of happy with the question is interesting, you will sort of go and solve it and then share the solution, and your paper might be peer reviewed, accepted. But here the factors are different. Fundamentally, the process is the same actually.
Okay, thanks, Vinit. Okay, anybody has the mic, wants to ask the question?
Hello. Yeah. So my question is like sir mentioned about the problems like global warming and all those important issues. So up till now it was a choice to work on those problems or not. But with certain government regulations and all those laws, it's now important for industries to go on this and with heavy hand and make more efficient machines or reduce emissions. But still now there is no such stringent regulations on academia. So still it's like ma'am said, it's free flowing and you can work on any issues I want. So I want to understand, like, is there an option or would it be a good idea to bring that rigidity into the academic research on working such problems, or maybe making sure that some part of that research goes into like that aspect?
No, my answer is that at least academia in India, and I imagine everywhere, we are already super constrained. So if you look at our carbon footprint, it would be very low compared to the Microsofts and Googles of the world anyway. We don't need an additional artificial regulatory constraint. We are already we need one more GPU, and we are. Please talk to the PhD students here who are trying to learn their LLM models and fine tune them and so on. We don't have 30% utilization and 20% utilization and things like that of our data centers. We are super optimally provisioned. It's not a problem we need to solve, at least for Indian academia, and my guess is not even for any academia anywhere in the world. On that said, it will be nice. I have actually worn the hat of infrastructure in charge here in IIT Bombay. We have a data center and so on. It would have been good if we could have applied some of our, at that time in my research, I was actually working on power performance trade-offs, and I was actually trying to connect it. Then we run into the same problems as practical people do, that this is an infrastructure that needs to run, and we cannot really apply our optimization research and so on to that infrastructure. I wish that we had the hands and the systems in place to do that synergy right on the campus, much better than we do. I'm hoping it will happen like that in the future. That's my answer.
I'll add a small point. I'm not from the research background, but if I were to choose research as a career option, I would not want constraints. There should be a choice for someone. So as someone mentioned, right, in corporates, industry research, you have constraints because you have to optimize for profit. But let's say someone doesn't like that, and then they take an alternative career choice of going to research. And then ultimately you end up with more constraints in your academic field. Then there is no point of getting it. There should be a career option where there is no constraint and I can do whatever I want.
That's academia.
I mean, just to give you some examples, in college, some of you can empathize, right? I was very sad when I graduated from IITB because the college life ended and all that. But I was very happy about one thing. In every semester, there used to be one course of not from computer science department, which was enforced upon us. I don't want to take names. I'm sure all of you know, all of you have those courses. And I absolutely hated them from the core of my heart. So that was the worst part of my 4 years at IITB, and I totally don't see why they should go on for MTechs and PhDs. And as you grow in life, your career options, your choices should open up, and it should not be constrained. When you are young, it makes sense to put more constraint because you don't know the syllabus of your life. But like, think of it, if I'm starting a business and I'm told, no, you cannot start a business in software, you have to do only automobile engineering. That's not the right thing, right? As I'm growing up, my choices should open up. So for PhDs, it absolutely makes no sense to put constraints.
Okay, next question, please.
Hello, sir. My question was to Shivram, sir. So recently, there's controversy where DeepSeek launched a model R1, and it was costed around $6 million, and whole NASDAQ and whole Silicon Valley goes down, and NVIDIA goes down 17%. And people said, like, if we can train a model 673 billion parameters at 6 million cost, and GPT-4 costed around $100 million to train. But I think training a model from scratch like GPT-4 did is a hard, and reproducibility is like comparatively easier. So what do you think about that? Like, because GPT-4 created that model, like OpenAI created that model from scratch.
So what is the question?
So like question was like the whole Silicon Valley and whole NASA went down because they thought that a model can be trained with $6 million, but it was like they reproduced that model because OpenAI already did that. So what do you think? Like, is it a fair argument that a model can be trained in $6 million?
Frankly, I don't work on LLM technology, so I don't really know the technical feasibility of whether you can reproduce. Nagaraj is probably like better equipped. So let me hand him the mic.
Yeah. So, by the way, the verdict is still out, I think, on that debate. Whether what the actual cost they spent is, mainly because I think the costs don't take into account the actual training time that went into building the DeepSeek V3 base, which is an 800 billion parameter model, right? So someone has to have trained that model to be very good, so that you can then do whatever they did to get to R1. So there are lots of hidden costs involved, and we don't know what the true costs are, what the actual hardware that supported the training is, and where they got the data from. So there are lots of open questions, and anyway, it doesn't matter to us. What matters to us is that they actually put the code out, like put the technique out, and that's all matters. And the best thing about all this fiasco is that something has been shared with academia for reproducing things, and there's been a flurry of work since R1. And lots of healthy debate, and I think that's all we should take from all these things. Yeah.
So it says here, and this is to Vrunda, the NVIDIA CEO recently mentioned that they have AI working 24/7 to design new models and chips for them. With AI-driven automation playing such a critical role in hardware innovation, how is Intel leveraging AI for chip design and optimization? Do you see AI fully automating semiconductor design in the future, or will human expertise always be essential?
The basic thing I would like to say that nobody knows the future. So yeah, it is doing things, but it still will take some time. It's not up to mark. It has many things to do yet. For example, in my work, I do not see right now it is working. Like I work in proofs, so getting proofs. And I've seen like AI is not giving full proofs for many simple things. Another thing, Intel is working on it. Yeah, it is catching up with other companies. More details. I think I'm not able to say that about it.
Okay. Anybody else wants to add to this, especially from the semiconductor?
So I can't answer specific to the Intel company, but in general, if you ask this question, because this is a huge debate actually, like would AI replace normal workforces? But this question has existed throughout the 20th century. So if you look at 1930s, if you look at 1960s, if you look at early 2000s, these questions have always existed, whether the new upcoming technology would replace the existing labor force. This is like a question that has come and been persistent throughout. And if you see the data, it's yes, the current labor would get replaced, but always new labor is formed. So the new AI would definitely, like the tools that AI is going to help build would generate new kinds of labor. So the definition of labor would change. Now, the real question that you need to worry about is whether the existing labor that is going to go away is going to be very quickly be replaced with the new upcoming labor, or it would take a lot of time for the new labor to come, and that means a whole bunch of people who are actually doing what they're doing right now would be replaced and they would have no jobs. And that is a real concern. So essentially for tomorrow's workforce, what is more important is that you learn transferable skills. So you learn skills that you can transfer to the next wave of technology or next set of skills that you might have to learn as to what is important. That's what I.
So we can keep that theme. There was another question here. I actually really liked. Again, I hope the person would have been here raising their hands. The last part of the question. The first was what we have already talked about a little bit. How are LLMs and AI tools changing the landscape of work and research, particularly in software and coding? And I think Nagarajan, you might have something to say about that. Aman, maybe you too. But the last sort of piece of this question was, what's the future of work? So, very nice broad question. Aman, maybe you.
So I'll give an example in our industry, right? So my company, for example, we build speech analytics solution for banks and financial institutions. So when you call a bank, you hear that this call will be recorded for training and quality purposes, right? You would have all heard of it. Behind the scenes, what happens? Any guesses? Anyone? So there is a human auditor who takes a random sample of call. So one telecaller typically does 50 calls a day. In a month, they do roughly 1,000 to 1,200 calls. And an auditor behind the scene picks up 3 or 4 calls per telecaller per month. And they have a quality sheet to fill. For example, they will listen to the call and say, did the agent greet the customer? Did they authenticate the customer before sharing any information? Did they ask the customer for feedback at the end of the call? Right? All those things which you do in a typical customer support call or a whatever. You call your Indigo Airlines or anyone. So these human auditors are actually doing this job of filling the quality sheet. Now, it's fairly straightforward to automate it to a large extent because what we did was you transcribe this call, take the call recording, convert it into text. On that text, you can run a language model. It's fairly straightforward to do prompt engineering and say, did the agent greet the customer at the beginning of the call, and write a detailed prompt that this is the meaning of greeting, right? I'm sure everybody who understands LLM can correlate. It's not rocket science. End result is that some of our customers are starting to repurpose their auditors. Repurpose as in moving them to different teams, which is essentially a better way to say laying off their auditors, right? So, of course, these auditors will have to find other jobs. Sooner or later, we are starting with the auditors. We will come behind the call center agent as well, right? With voice bots and voice AI agents coming in. So, as Vineet mentioned, what will happen is historically, I don't know if some of you know, before alarm bell came in, I read somewhere that there used to be a job where people will wake up others at 5 a.m. You can hire someone and say, wake me up tomorrow at 5 a.m. because I have to take a train. So they will knock your door at 5 a.m. in the morning. Alarm bells came in. These people lost their jobs, of course, right? Physical newspapers, I'm sure all of us have grown up with newspapers being delivered to our houses, especially those born in late 90s or mid 90s. But now my parents, for example, they have an iPad and they read Amar Ujala digital newspaper, Dainik Jagran, Amar Ujala and all that. So these kind of things happen. But as Vineet mentioned, it's a question of how fast the technology is being adopted. If that happens across 10-year period, then these people who lost their jobs, who saw their jobs going away, they have a 10-year period to find another job. And 10 years is a long enough time frame for people to find alternate jobs. But imagine that happening in 1 or 2 years. For someone who is, let's say, not so educated, not so tech savvy, these auditors, they are not very educated, not very tech savvy. For them, of course, it's not so straightforward to pick up a skill and then become skilled in that tomorrow. If this would have happened gradually, it would have made sense. But, ChatGPT was released, I think, November 2022, if I'm not wrong, right? So 2.5 years, technology today in India is here. Cloud, for example, has taken a lot of time for adoption. Even today, people use Tally on their laptops. The Tally is not on cloud, right? Tally on cloud and all is very rare. So all I'm trying to say that this technology will take away jobs. I mean, some of you might say, Aman, why are you doing this? If I don't do this, someone else will do it. Banks have this problem statement. They will ultimately get it done with someone else. So I'm not the culprit. Ultimately, technology is the culprit. But point I'm trying to make, AI will take away jobs. People will have to update their skills at the pace of AI, otherwise they will be jobless for a certain time frame. But ultimately they will find jobs. Maybe they will be jobless for 3 years, 4 years, 1 year, 6 months, whatever. But then they will have to find other jobs.
Yeah, so I want to take this question from the software engineering coding point of view, and I like 2 parts that Aman mentioned in his answer. One is this question debate has always existed, and the second part was that what is more important is transferable skills, right? And both these answers also ring true in the software engineering and coding domain. If you think about it, there has always been the quest for the ideal programming language, right? So C used to be the programming language, and we were tested on C, and interviews were on C, and so on. And then Java came about, made a big deal about memory handling and so on. And then Python came, and now pretty much everyone has shifted to Python. And of course, so people, but what enabled people to move from C to Java to Python is because the basics of all these languages are the same, right? Understand the notion of variables, data, control, and so on and so forth are the same. So if you pick it up in one, you'll be able to apply in the other. And just it makes our life easier when you go from C to Python. And the same is happening, just that we are going from Python to natural language, right? We are sort of going back to where things start in our minds, which is usually the language that you learn things on. And even here, developers will start to use these tools, right? People will embrace these tools. Just like today, when you write code in Python, you don't understand, not everyone is going to understand what is going behind the interpreter of the Python, right? You don't need to understand the inner workings of the interpreter, yet you can write a very good piece of Python code if you understand the basics. The same thing will happen in the future programming world as well. These tools that AI is going to help developers write better programs with natural language, they are going to be there to assist them. So even if you don't fully understand the AI behind it, you will still be able to produce very good code as long as you understand the interface and you're able to do this application of knowledge, like this transfer of knowledge.
Any questions from the audience?
I have some experience with LLM agents, sir. It seems to me that it's very difficult to debug them. Even small changes manifest as unpredictable outcomes, and they're extremely computationally expensive to run. So how is the industry solving these kind of problems?
Yes, this is a question that requires a lot of discussion, debate, and so on. By the way, that's not a problem. That's by design, right? I mean, LLMs are statistical machines, so they're supposed to behave like how they're behaving, and it's our job to build the scaffolding, all the guardrails that we want to build around it. Agents part, yeah, I mean, you can call it agent. I can just call it a model. At the end of the day, it boils down to the stochasticity of the model that's behind these agents, and the reason they are doing so well is because of the stochasticity, right? If they were deterministic, they wouldn't be as well as they are today. So we have to think about how to build these guardrails and scaffolding around these agents so that we can succeed in the applications that we are actually putting them into. Yeah.
So actually, I'll segue to maybe Priyanka here, because your question was about efficiency and using a lot of resources or something like that, right? So can you give a systems view on this?
Yeah, so as ma'am said, right, LLM agents, you said it's not resource heavy and a lot of things, in fact, I'll go to Shivram sir that there are a lot of things that global warming thing or anything, they require a lot of compute, right? And GPUs are scarce. Even if industries have a lot of GPUs, getting them in the industry is also a challenge because there are a lot of people, everyone needs them, right? So you're doing them, scheduling them efficiently on these GPUs is something that's an open problem, that's open research problem that system folks like us are solving that way, right? So there is a problem there and we need researchers and engineers like us to solve that problem. Yeah.
So keep the mic, then I have a follow-up for you. We have a lot of second year, third year students, fourth year, maybe masters, first year also. So if some of those, if operating systems and networks or compilers or something like that, OS and networks you can answer maybe, if that's their favorite subject right now, but they are dreaming about being in either IBM research or somewhere, what is your advice to them?
Yeah, there is. I mean, I'll tell you, everyone feels LLM is the thing. You have to be a data scientist or you have to know LLMs to work in industry. It's not the case. I understand that's the top layer that everyone thinks. These are the applications that are being deployed or that are being widely used now. But underlining to run these, you need your systems knowledge, your system skills, right? You need these to be running efficiently on your GPUs. You need them. You hit, like if you run your LLM model, you'll hit out of memory, right? What do? You have to solve it going at the lower layers and solving them what needs to be done efficiently at the layer below, right? So we are scarce resource, if I'll say, but we are kind of required for smooth running of any system that's there running LLM models in the industry or in the world now.
Yeah, thanks. Okay, back to students. Yeah.
So I think everyone can answer this question. My question was that how can companies create programs or initiatives to identify and nurture R&D talent at the BTech level? Because like we can see that the big companies, they mostly hire R&D people from masters or PhD programs, and somewhere it feels like the BTech level, while they move to masters and all, they kind of lose the motivation. That is what I've seen with my friends and all. So I think that there's a need where companies need to nurture this talent at BTech level as well. So what are your views on that?
Yeah, I agree with you on that. But what companies are doing, in fact, IBM Research is doing, we run winter schools and summer schools in collaboration with universities so that we give opportunity for talent to learn things that are needed for the industry that we are doing on day-to-day basis, right? So you can join these winter schools that ACM hosts with us and be part of these, learn these these skills, right? Apart from that, what we support for BTech students to do is join our internship program, right? We have our internship programs every year. Our openings come out around August, September. I think most companies have that. You can join that, and there are no restrictions on if you should be a BTech or you should be a master's. We look for skills that can be applied and that can work with us on our problems. So that is another opportunity for you to come and work with us or come work in a collaboration.
Want to respond? Yeah.
Yeah, so I'll just go back to your first question. So, and Aman's answer. So, and I also have a vision on that. So, the most important thing, according to me, for like the next generation is to become the builder nation. Like, you really need to start thinking about how you can build products, and that requires people to not think vertically. You need depth, but you also need breadth. So if you understand what the building pipeline is, then it becomes easier for you to start coming into industry and contribute very quickly. So what we try to do is, so as like in what we do, it's very hard for somebody to come in and just start like immediately. So when they come in, we have to sort of introduce them to the building process and understand what it means to build systems at scale. So for people who are in their second and third years, when you're doing your courses, you should really try to understand what is the building activity, what you're learning, how it came about, why is it that you are being taught this, and what is the building activity that led to these courses that you're studying today. That is the building process that you need to understand so that you can come in and apply these skills across verticals. And that is important. So that's how I think. And probably offering courses from industry people who sort of can give you an idea how you can build things across verticals. That's how sort of you can help do this.
I'll add something. So, see, a parallel example. Why do top companies come to IIT Bombay or Delhi or IIT Kanpur or maybe top colleges rather than going to every college in India, right? The simple reason is that probability of finding someone who is chances of succeeding are high is more at top colleges compared to going to other unknown names, right? It's that simple. It's pretty much the same. I think companies invest in PhDs and masters from a research point of view because the probability of finding an alignment there is much higher. At BTech level, honestly, in my BTech days, I did an internship in Germany, TU Braunschweig, right? It's pretty, I'm sure it's known there. TU Braunschweig comes and hires interns. So I could not contribute much because I was still figuring out my career. Someone who has gone to masters or someone who has opted for a PhD, at least they have taken a career choice that they want to go for PhD. At BTech level, it's still a discovery happening. So now coming back, companies like IBM, companies like Intel, they are large corporations. They have a lot of capital, so they can take 5-year, 10-year bets and say, "Ki, I don't care whether I invest a couple of $1 million in hiring 10, 20, 30 interns across top colleges, and maybe just one of them ends up joining us. That's okay because we have billions of dollars of cash pile." With startups, it's not the case because startups don't have billions of dollars of cash pile. So they want to solve their tomorrow's problem. Tomorrow something is breaking, I need to solve it tomorrow morning, literally. That's how it happens in most of the startups, early stage companies. Silicon Valley, the trend is different because the venture capital ecosystem is very mature. So startups are well capitalized. Ultimately, all I'm trying to say, the solution to your problem is to go for companies who have big money. Because companies who have big money can take long-term bets. Companies who are seed funded, less amount of money, they cannot take very long-term bets. And so, like for example, we are seed funded, 20-member company. You can't expect us to come to IIT Bombay and choose researcher. But tomorrow, if my scalability of my software is breaking, yes, I will come and hire a BTech student or an MTech or whatever student who knows scalability and help me solve my problem tomorrow. So that's the difference of time horizon, and that's why go for companies who are well capitalized. They have the appetite to take some of the bets or go to Silicon Valley. Honestly, Indian startups are not the best when it comes to being a BTech candidate and applying for research position.
So you said, what should big companies do to nurture R&D? I'm not entirely sure what you meant by that. You want them to hire you directly?
No, I meant that I understand that from knowledge point of view, obviously BTech people are not that knowledgeable. Obviously, they'll go for masters and PhD candidates. But like while going to masters and PhD, what my friends think is that it is too much time to waste doing R&D. Like if they're not going to do it right after BTech, it is too much time they have to spend on themselves while doing masters and PhD. So what
Okay,
I
so
feel,
that I did have a opinion there. So no, I don't think there is a shortcut to doing research in industry labs. I think for doing a successful career in research, the combination of breadth and depth that you will get in postgraduate programs anywhere in the world is pretty much that is what industries are supporting, and indirectly industries nurture that by sponsoring. They don't want to do the teaching. We are here for them to send them a trained research talent. So I think there is no need for that role reversal. That's what universities exist for. We are doing the training. Yes, if they, like he said, if they have a lot of bandwidth in terms of cash and all of that to do the on-the-job training, they might do that also. But conventionally, they do prefer this thing that there is a professional ecosystem already existing for training research. Then let them do that. We just support that. So we have IBM fellowships, we have Microsoft awards, we have Google fellowships. They all support the existing training ecosystem, which is the universities, to train the talent. They also know, the good research labs also know that it's better to train somebody in a broad, through a university's thing with courses, with exposure to multiple talks going on and so on, before they come to us and start working with us. They know that route is better. That's why they prefer the PhDs and everything. So I think if you want to eventually get into research, don't try to do that. Don't take the shortcut. Come through the postgraduate and it will make you a better candidate for that, I think.
My question is somewhat related to cloud services and limitations of resources. So, this question is open to anybody of you. So, as we all know that it's all about data and data all. So, the question is that basically we have limited resources in terms of environmental and climate aspect of point of view, and in terms of technology as well. So we know that there is a lot, everything, it's all about data, whether we are talking about the LLMs that are trained on maybe GPUs, and also these all things require a lot of services, cloud related services. But we have limitations of resources. So I just want to know that what will be the peak level of this cloud services and resources, because we have limited resources. So maybe, but data is growing day by day. So what will be the peak level? That just I want to know that, and how we will handle this much amount of data at what that level when we have a very few resources are left. That is my question.
I'm not sure if resources are constrained, right? Resources are also growing. Moore's law says that compute is also becoming 2 times faster every 1.5 years. Not 2 times faster, like in the same amount of chip, 2 times more transistors are happening. So, I mean, your assumption, on what basis are you assuming that the resources on the hardware side are constrained?
Basically, it's not only the hardware side, but my concern is all towards the climate and environmental aspect as well. So because we have limited things as well in terms of material science as well, because whatever the data centers are made, that requires material science materials as well. So that point of view,
physical hardware, as in the space, and I don't know what you require, concrete,
I
cement,
think it's a really mature question. I think it's a great question. One person in this here realizes that resources from the planet are limited. They very much are limited. We cannot say that they are infinite. And we can see geopolitically what is happening for the people to just get resources from the earth and so on. All I would say is this is maybe a tea time and dinner time discussion. I don't know if anybody... I have a cynical answer, which is people who are trying to just get ahead, companies and even academia, because we have to publish and so on. Nobody's thinking about it. Nobody's thinking about the earth. Really.
So today we are all knowing about LLM only, and we are talking about LLMs only. So do we get to hear something new other than LLM from the industry for shaping the new future?
I'll come to the point that LLMs also came out of a paper in 2020, right? Attention is all you need is what started the transformer architecture, right? The things might not stay the same 10 years down the line, or there is a curve every time any tech or any industry comes into, like any tech comes into play, right? And I think things might change in a 2 to 3 years time frame as well if a new paper gets published or a new research gets done. So won't really be LLMs that way. So it might change over the years. So look out for that.
I also don't work on LLMs. I work on building cryptographic proof systems, ZKVMs.
Please, can you say a little more about it?
So ZKVMs are essentially these proof systems where you can run codes and generate cryptographic proofs. The idea is that once you generate the proof, anybody can actually verify this proof very quickly. And if the proof is sort of correct, then you can ascertain to the fact that the computation that was done was correct. Now, this is useful in many areas, but the main abstract use case is where there are multiple parties that are trying to verify computation done by a single party. Now, so you can bring the overall compute down by paying once the price, that the price is to generate the proof. You have to do 100x times the computation that is required for generating just the simple, like just computing the output. So this is actually a very nice problem, and this is like an ongoing research area as well, and you have interesting use cases that come out of this in the Web3 space. So it's not at all connected to LLM.
Yeah, so I want to add, so I work on LLMs, but then there is another viewpoint. So LLMs are a solution or a technology, right? But people in my lab, for example, they work on problems, not on the technology per se. So for example, there are people in our lab who is working to solve education for teachers, education for students. And there are people who are working with eye hospitals to solve, just to compensate for the dearth in eye specialists, right? So would you say these people are working on societal problems, or would you say that they're working on LLMs just because they use LLMs because it makes sense, right? Because the technology is powerful, so they will want to use the technology because their goal is to solve the problem using any and all means. And if LLMs are there to help them get there faster, then it makes sense for them to do this. So it's a perspective, I think. I mean, LLMs. I think of LLMs as a technology, as a device, as a means. But the problem I want to solve can be something very different.
So I wanted to just, Shivram, because people also equate as if working in AI is the same as working in LLM. Maybe Shivram, you can dispel that myth.
Yeah, so I think LLMs are so popular because they're facing you, right? You can go to ChatGPT and ask a question, right? But there is so much also happening behind the scenes, right? I mean, you have recommender systems recommending you products. You buy the product, it comes to your doorstep because somebody's planned the logistics. There is a lot of AI, ML in decision making, right, that is happening behind the scenes. There's work in robotics, right, nowadays, which is, I don't know, coming up with better robotic solutions for different things. So LLMs, I think, are so much popular because public easily sees it. But AI is also making inroads in, as Nagaraj also said, other areas, right? I'm working with somebody in chemistry, right, who's trying to optimize chemical reactions, right, using AI. It's happening in material science. It's happening in different sciences. You know, right, that the Nobel Prize winners in physics and chemistry last year were computer scientists, right? So, yeah, there is much more to it than just LLMs.
Yeah, thank you.
So we have a question from a faculty member.
Yeah, just a quick remark. So there was this question about research and can BTech students get into research quickly? So there's one thing that I have always noticed. There are two goals of research, and often only the first goal gets emphasized and second goal doesn't get discussed. So the first goal of research is, of course, to do something useful and develop something useful. But the second goal of research is to help researcher become much better intellectual individual so that he can solve the problem. This is the goal that is served in the academia. So first goal is served very well in the industry, and second goal is served very well in the academia. So if you want to be in research, as everyone is saying, perhaps don't try to rush. Develop yourself very well in academia, and then, of course, you have entire lifetime to solve the problems.
Geopolitically, how can India catch up with China? Like, China has their IP, they developed DeepSeek, but India has like mostly been a back office for most of the US. And our startups also mostly copy US, but despite like IIT Bombay is like leading in the most YC startups in our country. So like Y2K led to the IT boom in India, but that led to IIT coaching and then computer science craze. And now market is like saturated with the computer science jobs. But in US, as Kunal Shah said, 80% software engineering jobs are down. So like China builds, but India is on a risk of like its FDI IT engine. So where is the workforce, because it was a job creation for most of the workforce in India. So where are the next set of jobs coming, given the entropy is on the side of job cuts, but the serendipity is if we build some IP. And so, yeah, apart from Sarvam AI and other things, I've not seen other AI ecosystem in India. So where is the next IP coming that we can actually share to the world, and that will be in another IT boom in India? So that is my question.
Okay, so I did not completely get your question. So first part was India versus China, then about jobs.
IP, I think he's asking the
main
question of
question is-
are we going to... so Y2K was like not IP, but some opportunity. Yeah, what's the next opportunity for India?
So I feel product building in India, like Aman said, the VC market is not very mature here. You see any geography that has actually boomed in from 1952 till now, even China including, there has been a lot of capital infusion. Without capital infusion, you cannot expect to do some product building. Otherwise, you will end up doing service. So to build really good products, there are two things. One is capital infusion that is required into Indian markets. Second, Indians need to really think about what products they can build and they can distribute. So distribution is really key if you want, because building products today with the kind of tech that is coming out, it's not so hard. If you really sit and think, like you have LLMs, you can actually come up with interesting use cases that you can build. But what is really hard is to think about the distribution. How can you actually get your product into the hands of the people? And you really need a lot of capital to actually build foundational infrastructure level projects. And IP comes out of infrastructure level projects. And for that, you need simply a lot of capital. Because every company that exists today big is coming from outside in India. There is no Indian company. Sarvam also raised pretty good amount actually for them to build infrastructure. So people who are building foundational models, they have capital. So without capital, it's very hard to actually do infrastructure level work. That's the simple answer.
I'll add a small point. See, if you look at the overall landscape, one is the bottom layer, which is the hardware layer, which NVIDIA is specializing in, building chips, Intel and NVIDIA, those kind of companies. On top of that is the layer of foundational model, which is, DeepSeek, ChatGPT, right? Those kind of models built by companies like OpenAI, right? And Anthropic, right? All those companies. On top of that is the application layer, where I feel is the opportunity for India. For example, we are not building foundational models from scratch. We are saying someone has done that job, right? Now the banks, they don't have the, capability to attract the top tier talent from IIT Bombay or IIT Kanpur or whichever, top engineering talent. So what do? But they have a lot of problems to be solved, right? A typical large size bank in India has 30,000, 40,000 telecallers. ICICI Bank, if I'm not wrong, public data, they have 30,000 telecallers. Now, hiring so many telecallers, right? 40%, almost 30 to 40% of these telecallers leave their jobs every single year because they are not very well paid. Somebody pays them 1,000 rupees per month extra, they switch their jobs. So for these banks, it's a big problem to continue hiring these talent, retaining that talent and keep up with the growth rate of the bank, right? The credit in India is growing and so on and so forth. So somewhere they cannot use the foundational LLMs to solve their banking technology needs, which means entrepreneurs like me come to place and say, look, I don't know how to train my language model from scratch, but somebody in the US has done that. I don't know how to build chips, silicon chips, whatever, GPUs from scratch. Somebody has done it. I will borrow them. I will rent them. I will buy them, whatever. You tell me your problem statement and I will apply this language model which someone has built to solve your problem. So that's where I think a large opportunity for Indian entrepreneurs lie. Of course, if you enjoy research, if you like, getting deep into things of technology, go ahead, join one of the companies building foundational LLMs or building the next quantum computing chip, which can be much faster or something like that. But if you don't want, like for example, in my third year, I did a 3-month internship at a Silicon Valley-based startup. It's a company called Rubrik, which got listed in stock market. Some of you might have heard of them. But then I took a decision that I don't want to be in the US. I kind of not like the fact that I'm staying away from my family and parents. In the final year, I took a decision that I will start something of my own. And I and my company has never been into deep research because we don't have that capability. Can we build that capability? Yes, get some capital and all those things. It's a different direction. But I decided simple that someone has built the tech, someone has a problem statement who doesn't know how to use this tech to solve their problem. I will bridge the gap. That was the opportunity for me, and I think that's a huge opportunity lying for a lot of Indian entrepreneurs. Go to any large corporate. I'll give you a very good example, by the way. Last week, I met executive director of a very large bank, top 5 bank of India. In the meeting room, there was the executive director, there was their deputy CTO, there was their head of generative AI and head of HR, 4 seasoned leaders of the bank, and 2 of them from the tech side. They had invited me to take a talk, something similar, right? How can technology be used in banking, financial services, blah, 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 all those things, for the 4 of them. I started the question. They wanted me to help them evangelize generative AI within the bank, right? Among the top 1,000 people of the bank. So I asked one simple question to them. In the last 7 days, which one of you has used ChatGPT and how many times? There was dead silence in the room. Executive director has not used ChatGPT, I understand. Head of HR has not used, I understand. But deputy CTO, head of generative AI, has not used ChatGPT even once. And by the way, one of them is an IIT Bombay alum, 1990s batch. With all, I don't want to tell which of them. It becomes identifiable, but one of them is an IIT Bombay alum. Surprising that they are not using ChatGPT in today's era even once in the last 7 days. That's where the country is lying, and they have a ton of problems in the bank to be solved. They have zero idea how to solve it. That's where people like me come in, and we are building a company, we are employing people, more and more people are coming in, so not building foundational models at this stage. So that's to give you a sense of where is the opportunity I feel for India, application layer.
Thanks. Okay, we have almost exceeded our time a little bit. So I'm going to give the panelists a chance to say, not all, but anybody has something like they just really wanted to say, then just say it quickly, 30 seconds.
I'll just stick to the broad theme. So I think what we need to really focus on is, so I always think about when I joined my PhD and later part, I think about like what you want to do in 4 parts. What is the impact that you create? How much, so this from Ikigai, if people know Ikigai, what is the impact that you can create? What you like, whether you're good at it, and this is basically combined together. The second 2, it's you have to find your sweet spot. It's called the metaverse zone. And the 4th thing is what is the monetary compensation? Along with monetary compensation, you get materialistic, everything materialistic. And you have to find, it's like a weighted optimization. So you have weights for this. It's a very personal preference weights, and you have to optimize this. And I think if you choose and you optimize it properly, it's more self-satisfying.
Thanks, Vinny.
Yeah, I think I want to say the same thing. I was actually a little bit concerned that this is a panel on workforce of tomorrow. I mean, so many students sitting here. We've not really faced the fact that this choice is a very personal one, right? We are all very different people. So one of the very important aspects you have to consider while deciding what to do is yourself, right? Your aptitude, your strengths, weaknesses, right? The kind of things that you're comfortable doing, you aspire to do, your constraints in life. For example, a PhD, right? It can't be just another decision, okay, let me do a PhD. You need to commit time to it, right? 5, 6, 7 years, you have to cope with, failures. It's not really only your technical ability. It is a lot more about your, personality types, things like this, right? So I kind of assumed when we came to this panel that it would be more about this. It's mostly been around, technology and modern trends and so on, which is all very well. But finally, I think each of you making this choice, think a lot about yourself. You'll have to look a lot inward, right, before making this external choice.
Thanks, Shivram. Okay, so we can wrap up, or we have some thing for the panelists. Thank you from my end to everybody, Shivram, Nagarajan, Priyanka, Vrinda, Vineet, Aman. Thank you to the audience for really good questions. Really, really good questions.
Professor Uday, can I request you to please give the tokens of appreciation? First to Professor Shivram. Then to Professor Nagarajan. Next to Dr. Priyanka. Next. Now can I call Professor Rohit for the rest? Dr. Vineet. And lastly to Mr. Aman.